What's up, everybody? In this video, we are going to parse the serial data we read into the Arduino in the previous video. Parsing data means that it will take a long string and format it into smaller and usable pieces of information. Start off by logging into Tinkercad using your course username. Select Circuits in the left-hand menu. You will see our LED serial input circuit that we made in a previous video. Hover over the circuit and click on the blue icon that says Tinker This. Just a reminder that we are reading information from a Node-RED flow. The flow sends a string that follows the same pattern as JSON data. In the previous video, we used the serial.readStringUntil to detect the entire string. We can use the serial.readStringUntil to break up the string and read each value. Copy and paste the 3 lines of code in the if serial.available statement. Change the first input from a \n to a comma. Change the first serial print statement to first value, : Next, change the second serial print statement to second value, : Click Start Simulation and paste the string into the input box and press Enter. You will see that our program is reading the data into the serial port. It first reads data till it gets to the comma and prints it to the serial monitor. Next, it reads the remaining data until it gets to the new line and prints that to the serial monitor. Now that we have broken the string into separate strings, we need to identify the component and get the value within each. You will also notice that we have the curly braces in each string. We can use code to format and get rid of the extra characters. Right below the first serial.readStringUntil, add a line input.replace, open bracket, quotation mark, open curly brace, quotation mark, comma, space, quotation mark, close bracket, semicolon. This will search for the open curly brace and replace it with nothing. This essentially deletes it. Next, below the second serial.readStringUntil, add a line input.replace, open bracket, quotation mark, close curly brace, quotation mark, comma, space, quotation mark, close bracket, semicolon. This will search for the close curly brace and replace it with nothing. We have used the replace function to search for and delete the curly braces. Click Start Simulation and paste the string into the input box and press Enter. Now you will see that the strings printed to the serial monitor no longer have the curly braces. Next, we need to take each string and identify the component and the value that it is trying to update. In your code, below the first input.replace, type update LED, open bracket, input, close bracket, semicolon. What did we just do there? We created a function called update LED and passed the string we read from the serial port. Next, we need to write the function. At the bottom of your code, type void update LED, open bracket, string, space, input, close bracket, open curly brace, close curly brace. This creates a function called update LED and tells the function to accept a variable that is a string. The string will be the content from our serial read. Inside the curly braces, we want to write some logic that will search for the component and get the value that needs to be updated. To do that, we can use a function called indexOf. IndexOf lets us search a string for a value, and it will return the index of the value if found. If it doesn't find it, it will return a value of -1. Type if, open bracket, input.indexOf, open bracket, quotation mark, analog LED, quotation mark, close bracket, exclamation mark equals -1, close bracket, open curly brace, close curly brace. Remember, the exclamation mark equals means not equal to. So if the index of is not equal to -1, or if the analog LED string is contained within the string sent, it will execute the code. Inside the curly braces, type input.replace, open bracket, quotation mark, backslash, quotation mark, analog LED, backslash, quotation mark, quotation mark, comma, space, quotation mark, close bracket, semicolon. We're using the replace function again to search for the formatting of our string, and it replaces it with nothing, essentially deleting it. Now our input variable is only the value of the analog LED. On the next line, type LED value analog equals input.toInt, open bracket, close bracket, semicolon. You will notice that we have a function titled toInt. This converts a string to an integer. When we use the analog write function, we need to pass an integer. Add a call to the update LED function when we read the second part of the string. Type update LED, open bracket, input, close bracket, semicolon. This will use the same function, but pass the second part of our string. We need to add some code to the update LED function, so it will search for the digital LED value. We can cut and paste the if statement and make updates for our next value. Select the if to the end of the curly brace. Paste it right after the closing curly brace. Add else before the second if. Update the values of analog LED to digital LED. This part of the code will search for the digital values. Instead of updating the LED value analog, we want to update the LED value digital variable. Click Start Simulation and paste the string into the input box and press Enter. When you pass values from the analog and digital LEDs, you will see they update on the breadboard. The last thing to do is upload your sketch to the Arduino using the Arduino IDE. Next, ensure you have Node-RED running and open the flow in a browser. When you update the switch or slider, the LEDs on your breadboard will update. At the end of this video, you should be able to parse a string from the serial port and update components within an Arduino sketch.